Thank you. Thank you for this opportunity. I'll take the next 10 minutes to talk about some of the interesting challenges that are coming up, specifically in the area of AI and cybersecurity. As you know, AI has grown in multiple dimensions. It started off with just artificial intelligence, which was a collection of rules, if-then rules. And then over a period of time, this manifested itself as a machine learning concept, wherein there were certain statistical inferences done on the data to make certain decisions and predictions. And that again led into another form of another subset of machine learning, which we now call as deep learning, in which the system learns by itself to a large extent with vast amount of data and layered neural networks. So as we are seeing this transition from artificial intelligence to machine learning to deep learning, there is also it is actually, if you look at it, is basically driven by the requirements. And one very important requirement that we see is cybersecurity. I'd like to touch upon some small instances where cybersecurity can be fully benefited with the interference of AI, and then also list some very good challenges that one can attempt in order to make a mark in this field. Now, if you look at, there is something called a strong AI and a weak AI, or application-oriented AI. The strong AI goes from cognitive solutions to cognitive technologies to machine learning methods and to algorithms. These are generic topics spawning across multiple areas. And on the vertical side, where we look at application specific, we have all the way from information security to computer vision to autonomous driving vehicles to many of the things. So in all these things, one thing that is common is that we have a lot of data. We need to model the data. We need to validate that model. We need to test that model, then use the model and basically train that model, and then fine-tune that model to give correct results. And the essential platform here, essential need here is to basically identify patterns and use these patterns to make precise decisions and increase your precision and accuracy by carefully sensing these patterns. And these patterns may not be sort of characterized by a linear behavior. It can be multidimensional behavior. And so that is the bigger challenge that we are posing here. Now, as we look at, now this is all about AI, and now let us start looking at the cybersecurity part. The vulnerabilities are sort of constant, right? Today we have, what are the vulnerabilities? People are interested in data, so there is a leak of data. There are a lot of human omissions that are basically resulting in vulnerability. And there is also a most important thing, there's a lack of vulnerability management itself causing a vulnerability by itself, and there is lack of knowledge about the different threats, and then there are some insider threats. So these are all sort of classification of the vulnerabilities. And because of these vulnerabilities, what basically happened, can we go to slide number 4? Please move to slide number 4. So we have essentially a very big black market where, there are a lot of emails made available. There are, phishing attacks, malware activities, IP theft, and fraudulent domain. So there are quite a bit of things that are happening because of this data leak, which actually is in a position to basically give you some revenue for the hacker, or it can also be a state-sponsored thing where you can bring down another nation by this, what we may term as a cyber war. Now, the bridging thing between the the vulnerabilities and this black market, where how do we go and detect these things? There are multiple things that are available. There are open source intelligence. There are vulnerability databases, many forums, and lot of blogs, which basically exposes these things so that people can get that awareness. Right? And this is the setup that is available. So available. Now that the vulnerabilities and the information sharing and the information and these all never change. They are all seldom. But what is changing is the level of sophistication. Level of sophistication of how the attack is happening, how many agents are involved in them, and how it is growing. So these are all some of the things that make this entire thing challenging. And right from today we are seeing that we are seeing fifth generation sort of attack. First generation where just it was basically virus attacks, standalone PC, and mid 1990s you saw attacks on firewalls, early 2000 saw these type of exploiting vulnerabilities in the system, operating system, etc. And around 2010, there was a rise of targeted, unknown, evasive, polymorphic attack. Polymorphic attack in the sense that the attack can change signature so that it bypasses the firewall, many of the protection defense mechanisms. Now today we are seeing large scale multi-vector comes under different form, and the mega attacks that we are seeing, and it's also targeted towards institution rather than individual. Today is a mass cache in ATM rather. Right. So next slide. So as you see this, from over a period of time, the first of attack was basically driven by experimentation, or some just creating nuisance. The second was targeted about money. But then the third was certain personal gain, where you have IP theft and corporate espionages, insider attack, etc. And the last one today, which we are seeing, is all state-sponsored espionage. And then when you look at this is the worrying evolution of threats. And there is a matrix that you see on the right-hand bottom. There's a timely response, and then there is a timely detection. And today, many of the attacks are going into what we call as the type D, where we cannot have a timely response, nor there is a possibility of a timely detection. Right? So for example, today, if you look at your credit card transaction, if you're a bank, and then you have a tie-up with some of these card vendors, like you have all your cards. Now, as a bank, they know how much money is withdrawn through that particular card interface only on T+1. There is no real-time detection at all. So if you are attacked and you don't know that you are attacked, next day morning you will see that only 24 hours later you will be in a position to find out there is a discrepancy, right? So even real-time reconciliation doesn't exist, and these type of things are really creating problems in the financial sector. I just gave you an example of how Type D highest vulnerability systems exist today, right? So next slide. So this is the threat landscape, and you see some 10 biggest data breaches of 2018, right? And then there were some data breaches that came later, but these were all the initial things that essentially caused a real interest in trying to bring something more than a manual intervention or a rule-based system, something more intelligent to handle cyber threats. From the point where you start doing a commercial transaction, what you see on the top side of this slide, from a single system where you could have malware or phishing, from there you can have a man-in-the-middle attack on the network, and then there can be a distributed denial of service type of things in the DNS, and then on your cloud where you are doing your transaction on your bank server, etc., where centralized service system, you could have multiple types of attacks, including cross-site scripting and many zero days are those for which there is no known solution, but the attacker force before a solution comes. And these are all the worrying lands. Next slide. So as we see how machine learning will come to AI, there are two things. AI is divided into two things. That could be what you call as a batch AI and what you call as a continuous AI. A batch AI is that you start training one batch of data and then update. Continuous AI is on the fly as and when you get new type of data, your system starts running, right? So when you learn, it's the difference. And on the other vertical side, you see unsupervised learning, where the system learns by itself on previous data that it has seen, and supervised learning. Now there are many cyber attacks that are possible, and solutions. For example, behavioral analytics becomes extremely important. How does the customer behave? And this comes under this continuous unsupervised class. Similarly, inside the threat direction, again it is something on the IoT security. India coming. This comes under that class. On the supervised side, you have network traffic profiling. Which is basically from a distributed denial of service type of attack that today, recently, many stock exchanges are having this DDoS attacks. And something intermediately, there are this network anomaly detection and what you call as command control detection. So people try to establish a command and control from a remote entity to come into the system and start implanting that malware inside your system. And on the batch and unsupervised, you have this rule set generation, and batch and supervised, you have malware detection. So this is how these are all the interesting challenges, and this is the classification of which AI technique can work for what. So, so a typical artificial intelligence-based cybersecurity system is what you see on the bottom left, where you have a set of, there is a supervised learning platform, there is also an unsupervised learning platform. So basically, these systems are built based on logs. For example, I want to do a network anomaly detection or a network traffic profiling, as you see here. So there's basically these logs of the firewall or log of the network is basically taken up, and then people learn at different time of the day. Very simply, on the different times of the day, what is the traffic, and then suddenly on one day at that time, if you see a larger traffic, you go and do a warning. It's a very simple thing, but much more complex things can be done. So these are the potential applications of deep learning, specifically from a security perspective. I've taken, say, five AI cybersecurity interest segments. For example, in banking, a bank wants to analyze large volume of video footage from the ATM machines to detect abnormal activity. So somebody comes to the ATM, he panics. I want to find out, and this is for say our largest bank, State Bank of India, has several thousands of ATMs and millions of customers withdrawing, and we want to do it on a real-time basis. This is a very interesting and very challenging problem, and this can be a path breaker. There is something done, but that's not there is a lot of scope for improvement. For insurance companies see suddenly some car has dashed. I would like to go and use deep learning to find out whether somebody is making a false claim or not. In the healthcare, similarly, a diagnostic lab wants to automatically identify potential abnormalities in humans. Similarly, for the auto industry, in terms of manufacturing, and for even government, we deploy things to find out if there is a volumetric attack, like a distributed denial of service. So deep learning basically has many applications, and many of this can be linked to the cyber security and the particular decision making in many of these things. For example, where there could be a fraud, right? So these are some very interesting AI/ML interventions that we could have. Next slide. Next slide, please. So the overall goals here is in 1998, if you take, that's the time where this internet boom, the biggest boom from a security perspective happened. They were looking at preventing attacks. Today, we have to look at prevent, detect, respond, and analyze these attacks. And So there are multiple attack methods. If you look at 1998, they were all static virus that sits in your system, it doesn't spread. And so people were looking at some signatures for this, and then they were able to ward off that. But when we start moving towards the 2018, where real cyber attacks started coming up, things started like hacking, email-based attacks and web links, and that things became like people started looking at behavioral analysis, and and they were having certain types of intrusion detection systems started coming up. Today, when we have things like ransomware and morphing malware, etc., we need a lot more of AI-driven targeted. Even AI-driven targeted attacks are there, where we put bots and it basically looks at the behavior, and based on the behavior, they start implementing malwares. So this is where we need sort of many things like very quick root cause analysis, because it is multiple systems that are running on top and trying to basically hit your system. For example, we are running a stock exchange, and there is a volumetric attack that is coming up. If this volumetric attack is sustained by the hacker successfully, say for half an hour, it means a big impact on the economy of the country for that day. So that is something that we need, and that is where an AI-driven sort of remediation is necessary. Next slide. So this is how an AI system can work. For example, what you see on the top side, how do we actually model these? Right? So we need to have an understanding of how hardware. So there's something called virtual machine detonation. You take this real world malware, put it on a sandbox environment, and see how it is this type of an analysis. And you also have a good it is a normal thing. It is a normal thing which is doesn't and see how both of them differ in terms of physical parameters. Like the and you can put the same VM in a detonated detonator, and also see if there are some comparisons here. Statistics and machine learning is also to find out how a goodware will differ from malware. And so this gives us a learning set. And similarly, on the IDS architecture, is an intrusion detection system architecture. These type of analysis is basically put into the classifiers, and these form the training set, and the real testing phases happen in this type of an environment. So today, if you look at a system, the way the other source of data is to have what we call as honeypots, where if you you mimic a system, the attacker just thinks this is a real protection system and does an attack, and you basically keep dumping all the logs and understand how the hacks are happening. Many countries actually learned how to do the hacking just by studying these honeypots. Next slide. And there also comes this adversarial AI, where there is a chance to basically go and use bots to basically confuse your AI-based system by putting wrong data into this. And so that is also something which is basically coming up very big, where there is an AI component which is going to find out if this data is an adversarial data and whether I should admit this as a part of my training or not. So that is also a very bigger challenge that is coming up here. And all these things are much possible in the cybersecurity region, because we are looking at multiple volumetric volumes of data, and that is going to really cause a major impact in these type of adversarial situations, where I could give different types of traffic very quickly. I can generate. Yeah, so this is a very interesting thing. So one of the things that could happen today is that if I really want to on a digital financial channel, the way a person is actually moving on the screen for different classes of accounts. Suppose I have a card account, I don't have a card account, I have an account, I'm just trying to open an account. The way the movement of the the different fields, whether I'm cutting and pasting. These type of behaviors can also be learned, and from that we can basically get to know whether there is a malicious attempt, or is it a genuine user, or is trying to is it a bot or something else, and so we can do these type of anomaly analysis and come to certain conclusions. So the entire, to sum up, so I just wind up here. Sum up, we have a big domain in front of us. There are quite a bit of challenges. There are a lot of data that is going to be generated. Given the privacy, anonymization, etc., if the bank could actually, if a financial institution or any of this power sector, everywhere, each of the critical sectors can actually carefully analyze and put this data, we will be in a position to build up AI systems which can give sufficient warnings against these type of malicious actors, and hence make us cyber safe. And India has a great potential to do that. Many academic institutions have courses specifically to train manpower to handle these type of complex scenarios, and hope we'll get a lot of Indian-based solutions to prove our Atmanirbharta in AI, specifically in the context of cybersecurity. Thank you very much for this.